So there was a problem with network. You might have got the new link and informed your friends also. Okay, na? So good morning to everyone. Fine. So I think Jannavi, she had written about Grignard reagent that was related to preparation of alcohol by using Grignard reagent, right? So that's what we have discussed. Now, with respect to Grignard reagent, which chemical or which reagent is going to react? Can anyone? Which was that reagent which used to be reacted with Grignard reagent? So it was alkenes, right? Mayank is telling, not me. Anyone? It was carbonyl group containing compounds, right? So it was a carbonyl group containing compounds. So that's where we have the carbonyl group, right? So which will be reacting with Grignard reagent. Now, depending on the which functional group, so R is going to vary. So what I mean to tell here is, to be short, when it comes to ketones, with Grignard reagent, it will form which type of alcohol? It will form tertiary alcohol, right? So it is going to form the tertiary alcohol, because even this R will come and attach to carbon. Same way, if I take aldehydes, then I am going to get, can anyone, where R will be H, right? I am going to get secondary alcohol. I am going to get the secondary alcohol. But if I take formaldehyde, then situation will be different, because here also it will be H, here also it will be H. So it will be leads to formation of primary alcohol, right? So that is nothing but methanol. Sorry, primary alcohol, not primary alcohol even. Yes. So that is methanol. Okay, no, primary alcohol. Whatever I have written was correct. And we saw it's going to form which one? It's going to form ethanol, depending on which R is there. Now, next one. Whether carboxylic acid we have discussed? No. With respect to Grignard reagent, we have not discussed with respect to carboxylic acid. That's what we have discussed in the last class, right? So here, so methanol is not the one, because we have R here. So it should be any other thing which will be decided by which R group, alkyl group is present. So that is one preparation we have discussed. Now, with respect to the preparation of phenol, right? With respect to the preparation of phenol, first we have discussed about Dawes process. That is conversion of chlorobenzene, right? Chlorobenzene to respective alcohol. That is nothing but phenol. So that's where we have the Dawes process. It will be done in the presence of sodium hydroxide, right? Then we have discussed conversion of benzene to phenol. How it will be done? How benzene can be converted into phenol? So there are two categories. According to your textbook, only one is there. So where it will be in the presence of oleum, and then it will be presence of sodium hydroxide, right? Next step will be presence of sodium hydroxide. That's where I am not going in detail. That's where benzene can be converted into phenol. So another method here it will be, first we have to convert benzene to nitrobenzene, right? It can be done by utilizing HNO3 and sulfuric acid. Then from nitrobenzene we can synthesize aniline. That is aminobenzene, right? So from aminobenzene we can be getting phenol, right? By diazotization process, where we will be getting intermediate as benzene diazonium chloride. So that's where we have the conversion of benzene to phenol and benzene to phenol, two methods. But according to your textbook, in this topic they have given aniline to phenol. Don't get confused. So it is given from aniline to phenol. So then we have discussed another very important reaction, that is Cumin process, right? So which is nothing but Cumin process. What do you mean by cumin? So cumin is nothing but isopropyl benzene, right? So that's where we have the cumin. So what will be the IUPAC name? 2-phenyl propane, right? So that's where we have the cumin as a reagent. So in cumin process what they will do? They will utilize hydrogen peroxide, or they will be utilizing oxygen. So they will be utilizing oxygen. Okay. So that's where we are going to get the peroxide as the intermediate. We are going to get the peroxide as the intermediate, which later can be converted into phenol by acid hydrolysis. Right? So that's where we have the reaction. Yes, Janam. And another important product we are going to get here is acetone. So this is one of the method for the commercial preparation of phenol and acetone. Fine. So all of you have understood. So that's what we have discussed with related to preparation. And please remember, Cumin process is very, very important for your exam point of view. Okay. So now that is one thing. Then we have discussed about physical properties. So where we have seen intermolecular hydrogen bond is the one which is going to enhance boiling point of alcohols and phenols compared to hydrocarbons or ethers. That's where intermolecular hydrogen bond, since it is present in alcohol and phenols, they will be having higher boiling point. Now, same reason, due to the presence of intermolecular hydrogen bond between water and alcohol or phenol, they are soluble in water, right? So answer is same. So what is that? One is, question will be, why they will be having higher boiling point compared to ethers or hydrocarbons? Answer is due to the presence of intermolecular hydrogen bond. Next, why alcohols are miscible with water? So answer is once again same, due to the formation of intermolecular hydrogen bond between alcohol and water. Fine. So that's what we have got the concept. These are the concepts which we have discussed in the last class. Any doubts in those concepts? So in that case, shall we move to the next one? So next one is chemical properties. Next one is chemical properties. Now, when I am talking about chemical properties, we have OH. There can be two types of reaction which can be shown by alcohols or phenols. Okay. So in one case, there will be breakage of the bond present between oxygen and hydrogen. So that's where there will be formation of alkoxide ion, okay, plus H plus. So this can be one type of reaction. Under different condition it will be decided. Now same way another reaction will be where there will be cleavage of the bond present between carbon and oxygen. What is our alkyl? So that bond can be cleaved where we are going to get carbocation plus OH minus. So there can be two types of reaction, right? So depending on which condition we have provided, a reaction will be decided. Whether I am clear? Okay. So normally this type of reaction will be shown by protonated alcohol. Anyway, we'll not go in detail. Whenever I'll be talking about chemical properties, that time I will tell which bond, or you can observe which bond has been cleaved. So what I mean to tell you is chemical properties of alcohol will be decided by naturally due to its functional group, which is that one OH group. So OH group can undergo with two different way, which cleavage of the bond. One will be present between O and H, and another one will be due to cleavage of bond present between carbon and oxygen. So there are two types. Okay. So two types of cleavage of bond. Whether I am clear? So first we will go with the OH bond cleavage. So we will go with the cleavage of OH bond. We are going to discuss those reactions which involves cleavage of oxygen and hydrogen bond. Okay. Now in that case, first one will be, we have alcohol. Okay. So when I will be treating with sodium, that means metals, reaction with metals. So that's where I have the sodium, and all of us will know sodium is like a electropositive metal, electropositive element. So therefore oxygen will not become selfish now. Oxygen will not become selfish. It will donate its electron, it will keep it with itself, and whatever electron belongs to hydrogen, it will give it to hydrogen only. So that's where there will be homolytic cleavage, because sodium is there to satisfy the oxygen. Sodium is there to satisfy the oxygen. So that's where I am going to get RO minus Na plus. Na plus. So minus plus, no need to write, but even if you write, no problem. So that's where it is sodium alkoxide. Sodium alkoxide ion. Okay, otherwise, since sodium alkoxide is there, no need to write ion. Sodium alkoxide will be formed. Right? Now, one hydrogen atom, it is released as it is. So therefore, another molecule with same type of reaction with another sodium. So where there will be RO Na plus, another sodium alkoxide, and whatever hydrogen are released as hydrogen atom, they will be formed bond with each other, and there will be formation of hydrogen gas. Right? So what I mean to tell you is two molecules of sodium hydroxide will react with sodium, two elements or two atoms of sodium, to form two molecules of sodium alkoxide and hydrogen gas. So that's where I can write the overall reaction OH to sodium, which will give rise to two molecules of sodium alkoxide plus hydrogen gas. So that is the reaction. Fine. So that's where we have the reaction. Okay. So why hydrogen is not released as H plus? Why hydrogen is not released as H plus? Because sodium is present. Okay. Sodium is telling to oxygen, don't worry, I am here to give the electron, leave the hydrogen, don't take hydrogen electron. So that's what oxygen will do, because it got the assurance from the sodium. So therefore H plus will not be released. Please remember, many students they will write release of H plus. No, in this case there is no release of H plus. Due to release of hydrogen atom, therefore there will be formation of hydrogen gas. Right? Same reaction even with aluminium. Same reaction even with phenol and sodium. So where if I take phenol, when it is treated with sodium, same type of reaction, two molecules. So there will be formation of two molecules of sodium phenoxide. What is this? It is nothing but sodium phenoxide. There it was alkoxide. So here it will be phenoxide plus hydrogen. This is what will happen with respect to phenol. Okay? Any doubt? So if I take aluminium, say for example, I will take aluminium. Okay? So when it is treated with aluminium, naturally it demands 3 molecules of alcohol, because aluminium can go to +3. Aluminium will go to +3. So therefore it will take 3 molecules of alcohol. Normally tertiary alcohols, they will react with aluminium. That also 3 molecules. Why? Because aluminium can donate 3 electrons and can attain Al plus 3, because aluminium cannot go with Al plus, or aluminium cannot go with Al plus 2. It should end up with Al plus 3 only. So therefore 3 molecules of alcohols will be reacting, and normally it will be tertiary alcohol. Okay? So that's where we have the reaction. Fine? Reaction with the metals. Now another extra property of phenol compared to alcohol here is, when phenol is treated with sodium hydroxide, other alcohols, they will not show this reaction so easily as that of the phenol. Remember, other alcohols, they cannot show this reaction so easily as that of the phenol. Okay? Now, what is another name for phenol? Phenol is carbolic acid. That is the answer. This reaction is the answer for that particular name, acid. This will go for neutralization reaction, just like acid and base. They are reacting with each other. So what should be one of the product? Neutralization reaction means. What should be one of the product? One of the product will be water, because OH minus H plus. Now remember, H plus will be released. That is the difference between reaction of metals like sodium and reaction of sodium hydroxide. Yes, Janavi, very good. Another product should be naturally sodium phenoxide, because here it is positive, means positive only. Now there will be cleavage of the bond, that is heterolytic cleavage. Here H plus will be released. Therefore we are getting water. Okay? So and another product, as Janavi, as she has written, it should be sodium phenoxide. It will be sodium phenoxide. So that's where we have the acidic character of phenols. That's what I told. With respect to other alcohol, this reaction is not much prominent compared to phenol. Okay? So that shows the acidic character of the phenol. H plus OH minus will be released as water. Neutralization. Okay? So that's where we have the neutralization reaction. Okay, that's where we have the neutralization reaction with sodium hydroxide. But with sodium, there will be liberation of hydrogen gas. There is no water. Okay? So whether I am clear? So other alcohol with respect to sodium hydroxide, this reaction will not happen so easily. That shows that phenols are more acidic compared to alcohols. Although both of them they are having OH group, but still phenols are more acidic. That one we are going to discuss in another 2 to 3 minutes. But whether I am clear? So now that's where we have to discuss about acidic character. That's where we have to discuss about acidic characters of alcohols and phenols. Right? Because since we are discussing about cleavage of the bond present between oxygen and hydrogen, it can go with O minus and H plus. Right? That's where acidic character of alcohols. Right? Now in that case, you can expect the question in such a way that I have hydrogen, OH. What is this? Methanol, CH3OH. Okay, this is nothing but methanol, CH3OH. Sir, mat sumne seedha bariyadalva CH3OH anta. So to make you understand, I have written like this. Next, we have R, H, OH. So what is this? This is depending on the R. So in general, we can consider this one as primary alcohol. This is a primary alcohol. Next, we have R prime, H, OH. What is this? This is secondary alcohol. Right? This is nothing but secondary alcohol. Then we have R, C, R prime, R double prime, OH. So that's where we have the tertiary alcohol. Sir, what is this prime, double prime and all indicates? It's just to mention that they are different alkyl groups. They can be same. All the R can be same or they can be different, whatever it is. Okay? So that's where we have the three types of alcohol. So methanol, primary alcohol, secondary alcohol and tertiary alcohol. So among these four, which should be the strong acid? All of them, they are alkyl alcohol. They are not, have not mentioned anything about the phenol. All of them, they are alkyl alcohols. Can you tell me? I will give a hint. You people have discussed one concept in your first PU, inductive effect. So based on that, it is the answer. Now all of you will agree oxygen is electronegative. Now due to that, what will happen? These alkyl group will be pushing their electron towards the oxygen through carbon. Right? Same logic we can find here also. Same thing we can find here also. Now wherever alkyl group is there, we all of us we know that alkyl group can show positive inductive effect. They are electron donors, not withdrawing, donors. So that's where we have the alkyl groups. Therefore, as there is an increase in the number of alkyl groups, now this oxygen will be happy because more electrons are coming towards its near to it, right? So that's where we have the positive inductive effect. Due to that, oxygen will not giving torture to hydrogen, right? But here, since there is no alkyl group, oxygen will not have much electron near to it. So therefore it will be torturing the hydrogen. Give me my electron, give me my electron, it will be torturing. So therefore, poor hydrogen will be released as H+. So what I mean to tell here is, based on positive inductive effect concept, based on positive inductive effect concept, where as there is an increase in the alkyl group, as there is an increase in the number of alkyl group which is attached to the carbon, which is attached to the OH, that is important, okay na? So that's where it's going to decrease the acidic character. So therefore I can write whatever I have written, it is the decreasing order. It is nothing but decreasing order of acidic character. Whatever I have written, it is the decreasing order of acidic character of alcohols. Fine? So that's where alkyl alcohol, this is the arrangement with respect to decreasing order. Right? Yes, Amit. Methanol will be bit stronger acid. Strong acid in the sense, don't compare with HCl and all. We cannot compare acidic character of HCl with this alcohol or sulfuric acid with this alcohol. They are very, very strong acids, no doubt. These molecules are not at all comparable to those acids, okay? But among themselves, if I consider, that's where I have the methanol as the strong acid, then comes the primary, then comes the secondary, and tertiary alcohol will be much, much weaker acidic in nature. Okay? Fine? All of you have understood? So this may help you out in your competitive exam. It is there in your textbook also, no doubt. Okay? So that's where we have the acidic character. Now, if I want to compare alcohols with water, if I want to compare alcohol with water, right? Now, among these two, which will be more acidic in nature? Which will be more acidic in nature? How to give the answer, right? So, I am not telling plus here. I want to compare. Otherwise, nothing will happen. They will mix with each other. That's all. Right? Now, that's where we can prove this one by taking alkoxide. By taking alkoxide. When I will mix with the water. When I am going to mix with the water. So, during that time, there will be formation of any answer. There will be formation of hydroxyl ion and alcohol. Hydroxyl ion and alcohol. Which alcohol? Decided by which alkoxide we have taken. So that's where we have the alkoxide ion which is treated with water. Then the product will be alcohol and hydroxyl ion. Right? Now you should tell me, if that is the case, which will be a strong acid? It should be a strong acid, water or alcohol? It is based on first year thermodynamics, chemical equilibrium, where we have discussed conjugate acid and conjugate base concept. Now please remember, if I take alcohol and alkoxide, so this is conjugate acid. Alcohols are conjugate acid and this is conjugate base, because they differ from each other by 1 H plus. That's where conjugate base and conjugate acid. So alcohol is the conjugate acid of respective alkoxide ion. Alkoxide ion is the conjugate base of respective alcohol. Why I am telling respective? That is because R, it should be same. We cannot compare. For example, this is ethanol. Now I cannot compare with methoxide. No, I cannot compare with the methoxide because both are from different source. So therefore, R group should be same. So that's where we have conjugate acid and conjugate base concept. If you recollect, because all these things will be help you out in competitive exams. That's why. So if that is the case, conjugate and conjugate base concept is there. Now I have taken conjugate base, which is getting converted into conjugate acid. That means this is a good acceptor of H plus. Acceptor of H plus. That means it should be a strong base. It should be a strong base. Alkoxide is taking the H plus and it's becoming acid, that is conjugate acid. So therefore alkoxide ion is a good acceptor of H plus. It is taking H plus from water. So therefore it should be a strong base. Right? Now if you recollect, everything we were discussed in chemical equilibrium, right? As the conjugate base will become strong, as the conjugate base will become strong, conjugate acid will become a weak acid. As the partner is becoming strong, this will become weak. If this is strong, this should be weak. Whether I am clear? Since conjugate base, that is alkoxide ion, are strong base, therefore alcohols are weak acidic in nature. Weak acidic in nature compared to what? Compared to water. Whether I am clear? Right? Whether I am clear? Since alkoxide ions are strong base, therefore alcohol should be a weak acidic or weak acid compared to water. Water can be considered as bit more acidic compared to alcohol. Whether I am clear? All of you have understood? Any doubts? If I want me to repeat, I can repeat.
So why can't you consider the reaction like opposite? Even OH minus is a good acceptor of H plus.
I'm not getting. OH minus is?
Also a good acceptor of H plus.
Yes.
So
that's
that is also strong.
I will come to that. Compared to this, okay. That was actually next one, but now only Mayank has asked. So OH minus is also very good acceptor. Therefore, I will give a statement. Observe here carefully. Sodium alkoxide is a strong base. Is a strong base compared to sodium hydroxide. Sodium alkoxide is strong base compared to sodium hydroxide because conjugate base is a strong base. It will accept H plus much more faster compared to OH minus. That's what I wanted to tell. This is the conclusion. Okay? So all of you have understood. If this is the case, what it indicates? It indicates that alkoxides are much more good acceptor of H plus compared to OH minus. All of you know sodium hydroxide is alkali, strong base. That's what we used to think, and it's true also. But if I compare sodium hydroxide with sodium alkoxide will be much stronger base compared to sodium hydroxide. Whether I am clear? Whether all of you have understood? Any doubts? Let me know. Once again I will tell, don't worry. Now when I am talking about alcohol, they are bit acidic, no doubt. Okay, they are bit acidic in nature. Now why they are acidic? Because there is a provision for alcohol that there can be cleavage of bond between oxygen and hydrogen. So therefore there will be release of H plus. Therefore they are bit stronger acid. Yes, Samir. Fine. So that's where we have the acidic character of alcohol. Now if that is the case, now whenever alcohol is going to donate the H plus, whenever they are going to donate the H plus, what we are going to get? Alkoxide ion. What we are going to get? Alkoxide ion. Now I want to see whether alcohols are a bit stronger acid or whether water they are stronger in nature. I cannot judge by adding water to alcohol or alcohol to water because we cannot identify. They will be miscible with each other. Products we can see, but still they are miscible with each other. So therefore what I will do is I will take the alkoxide. I will take the alkoxide and when I will add it to the water, now there will be formation of alcohol. So that indicates that water is donating the H plus to alkoxide. So therefore we are going to get ROH. So therefore we can tell that water is a stronger acid compared to alcohol, because when you add water to the conjugate base of the alcohol, we are getting alcohol. So therefore alcohol should be a bit weaker acidic in nature compared to water. This is the reaction which justifies. That what is that reason? That is because whatever conjugate base for alcohol is there, that will be a strong base, because it is accepting the H plus easily. Even from water it is accepting the H plus. So therefore it should be a strong base. Since conjugate base is a strong base, its conjugate acid should be a weak acid. It will not donate the H plus, because it will hold the H plus, it will not going to release the H plus. So therefore alcohol should be a weak acid compared to water. That's what I have explained. Now what is the conclusion? The conclusion here will be, if I take sodium hydroxide, a base, strong base, if I compare with the sodium alkoxide, now I can tell that sodium alkoxide should be much stronger base compared to sodium hydroxide, because alkoxide itself is taking H plus and there is a formation of OH minus. OH minus, once again it is not taking H plus from here, right? So therefore sodium alkoxide, that is alkoxide ion, is a strong acceptor of H plus even compared to OH minus. If OH minus would have been a strong acceptor, then the reaction would have been reversible, right? So that is not happening. H plus is not taking back the H plus. OH minus is not taking back the H plus. Reaction is not reversible, right? So due to that we can tell that sodium hydroxide is weaker base. I am comparing with sodium alkoxide. I am not telling sodium hydroxide is a weak base. No. Sodium hydroxide as individual molecule, it is a strong base. But when it compared to sodium alkoxide, it is a weak base. Sodium hydroxide is a weak base. All of you have understood? Fine. So these are some of the important concepts which may be helpful for your competitive exams. Fine. Can we move to next one? All of you have understood? Okay. So we will move to the acidic character of, acidic property of phenol. Acidic property of phenol. Now, phenols are also called as carbolic acid. That means phenols are pretty good acidic in nature compared to alcohol. Right? Phenols are acidic in nature. What is the reason why phenols are more acidic in nature compared to? Why phenols are more acidic in nature compared to alcohol? The reason is, one of the reason is resonance stability. Resonance stability in the phenoxide ion. Resonance stability of phenoxide ion. How this phenoxide ion will be formed? Phenoxide ion will be formed when phenol will going to donate the H plus and when it will become O minus. That's where we have the phenoxide. Okay. So that's where there will be formation of the phenoxide. We have seen this one as sodium phenoxide. That's all. Right? That's where phenol can be converted into phenoxide ion. Now what will happen? Since we have the benzene ring, O minus, right? They are going to push the electron towards the ring, benzene ring. They are going to push the electron towards the benzene ring. Now due to that, this electron will be pushed here. So there will be formation of double bond here and there will be negative charge over here. There will be formation of negative charge over here. Why oxygen is not gaining positive charge? Because oxygen is not donating its electron, it's donating extra electron, whatever it has got, that is negative. So therefore don't write positive here. Okay? Now, next step here is resonance. So now the electron will move to the next position. Oh, so it will be moving here, and the next electron will move here. So therefore there will be condition like this, right? Finally electron will be back to oxygen. O minus, right? So that's where we have the resonance. Double bond positions are altered. Double bond positions are altered. Fine? So that's where we have the condition. All of you have understood? So if you remember, OH can show the positive resonance. If you go back to first PU, OH can show the positive resonance. Here I am talking about phenoxide. If you are talking about OH as it is, okay, if you are talking about OH as it is, if it is going to donate its lone pair of electron, yes, then it will carry the positive charge. Oxygen should carry the positive charge, no doubt. But here I am not taking OH, I am taking O minus. So there is no requirement of giving positive charge to the oxygen. Fine? So since OH group is having positive resonance, right? And since whatever phenoxide ions are getting formed, they are getting stabilized due to the resonance effect. They are getting stabilized due to the resonance effect. Due to this reason, phenols can give the H plus bit easily compared to alcohol. Because whatever product will be formed, that is phenoxide ion, they are getting stabilized due to resonance. Fine? All of you have understood? Any doubts? So this is one of the major reasons why they are having strong acidic character. Phenols are having strong acidic character.
So is this called plus R or minus R?
Huh?
Is this called plus R or minus R effect?
This is positive resonance. This is positive. That's what I am telling. Alcohols, they will have the positive resonance. Because electrons are pushed towards the resonance, means ring structure. If electrons are going away, then it is called as negative. So alcohols, they will show positive resonance. Fine? So here it is a positive resonance. Therefore, there is a negative density. Electron density is more at ortho and para position. They are more at ortho and para position. Any doubts? Okay. So in that case, if you have understood this one, next one point is that we have OH, CH3. What is this? We have already discussed. We have already discussed this molecule in IUPAC nomenclature, if you recollect.
IUPAC. You don't want common name.
Common name you should tell, that's what I am telling. And I told, it's a bit important molecule. Anyone? Oh, my students, they are not sending the message now. Fast. Anyone? It is nothing but, yes, I was waiting. Yes, Janam, it is cresol. It is cresol, right? So, ortho meta para, it is p-cresol, right? So, it is a cresol molecule, right? Now, I will write another molecule, that is phenol only, and I will write another molecule. Okay. So what is this molecule? Whatever I have written in the last, which is that one, that is nothing but PNP, para-nitrophenol, PNP. So para-nitrophenol. Now, among these three, can you arrange based on decreasing or increasing order of their acidic character? Decreasing or increasing order of their acidic character. Can you arrange these three molecules? Okay, Amit. Yes, paratrazole, 4-methyl-phenol. Yes. PNP greater than phenol, greater than paracrazole. Very good. Or since I have written like this, I will write increasing order. Okay. So I will write like this. Increasing order of their acidic character. Increasing order. But whatever someone had sent the answer, it is absolutely correct. Since I had written like this, I have written like this. That's what I have made it as increasing order. Okay. So that shows that PNP is much stronger acidic compared to phenol, which is much stronger compared to crazole. What is the reason?
Inductive effect.
That is inductive effect, right? Or we can tell that, we can see here we have the molecule which can push the electron towards the benzene ring. So due to that, this effect will get decreased because already we have alkyl group, so even OH group. So both are electron donors towards the ring structure. But here we have the electron withdrawing group. Nitro group is a electron withdrawing group. So nitrobenzene, it will show negative resonance. Phenol, it will show positive resonance. So due to that, more electron will come towards the ring. So phenoxide ion will be much more stabilized. So that's where we have the para-nitrophenol, which can act as a strong acid. That's where we have the para-nitrophenol act as a strong acid. Okay? Any doubts? Any doubts? So due to that, what will happen? O minus will be easily found because it is what I can tell, it is pulling the electron towards itself. So OH bond will be cleaved easily. Oxygen will be under tension. Oh my God, my electron is taken by this nitro group, so it will torture the hydrogen. So H plus will be released easily. Okay? So any doubts in this? So as the number of electron withdrawing groups will increase, naturally it is going to have the higher acidic property. But it should be at ortho and para. More impact will be there compared to meta. That is important. Electron withdrawing group should be present at ortho and para. Then more impact will be there. More influence will be there. Not at meta position. Because in the resonance we have seen whatever electrons are going away from alcohol towards the ring, they are getting distributed at around ortho and para position. That is the reason. Fine? So any doubts? But please remember, once again I am telling, we cannot compare acidic property of alcohols with the HCl, H2SO4 like that. No. Simple reason, which value if I want to give, these alcohols or phenols, they will have somewhere around pK value, I am telling. pK value will be 7 to 10. I am not giving exact value, 7 to 10 pK value. But if I take HCl or sulfuric acid, now it will be in a negative 3 or 4. That's where we have the negative value. Can you imagine? We cannot compare these values, right? So because of that only I am telling that we cannot compare the acidic property of alcohols with mineral acids or orthoprotic acid like sulfuric acid and all. Fine? Whether I am clear? So these are the reactions which includes cleavage of oxygen and H linkage, oxygen and hydrogen linkage. Now we will come to next one. That is esterification. Okay. So I will mention this one as important. Esterification. Now when I am telling esterification, what do you mean by esters? What do you mean by esterification?
Sweet smelling compounds. Sweet smelling compounds.
Okay. Fruity odor, yes. How come smell will be sweet? It will be fruity odor. Yes. That's fine. That is one of the question in your viva boards with respect to your practical. Esterification, you can have the question. It is a test for finding the presence of carboxylic acid and alcohol. Now, what do you mean by esterification? Where we will be having alcohol and we will be having carboxylic acid. We will be having alcohol and we will be having carboxylic acid. Under acidic condition, there will be release of water and there will be formation of ester linkage. Once again, cleavage of the bond between oxygen and hydrogen here. Okay? So that's where we have the esterification. Water. It will be released. So these are called as, those molecules which are having these linkages are called as esters. Okay? Someone functional isomer of COOH. Which one you are telling functional isomer? Esters. No, esters cannot be functional isomers of carboxylic acid. Right? Purnima. Because esters are found when carboxylic acid and alcohols will react with each other. So there will be COO linkage. Fine? So that's where we have the esters, which will be having fruity odor. So this is the reaction where we can identify presence of alcohol or carboxylic acid. For example, I have a alcohol, but I don't know whether it is alcohol or not. So I should add carboxylic acid compound to it. I should provide acidic condition, and if I say the smell, if I am getting fruity odor, then it means that yes, there is a formation of esters and that solution was having alcohol. Fine? So this is one of the tests to find any of these two compounds. Okay? Now, in that case, very important one among this one is esterification only. Very important one here is we will be having one molecule called as what is this? IUPACine. I don't want common name. You can tell me IUPACine. Why so much time?
2-hydroxy benzene carboxylic acid. Benzoic acid.
Anyone? No, Shashank, it's not catechol. In catechol, no carboxylic acid group. Right? So this is 2-hydroxybenzoic acid. 2-hydroxybenzoic acid. That means salicylic acid. This is nothing but salicylic acid. Okay, so that's where we have the molecule. Now, when I will treat this compound, salicylic acid, this molecule with acetic anhydride. What do you mean by acetic anhydride? We have already discussed CH3CO, OH, OH, CO, CH3. So, two molecules of acetic acid. There will be liberation of water. So, there will be formation of O, CO, CH3. This is nothing but acetic anhydride, right? So H plus OH. Left over is oxygen. So that's where, since there is a liberation of water, it's called as anhydride, acetic anhydride. Okay? So in the presence of acetic anhydride, which can also be written as CH3CO twice O. Anything is fine. It can be written like this or like this. That is nothing but acetic anhydride. Okay? Now, in the presence of acidic condition, now what will happen? There will be acetylation. Because acetyl group will be formed. Either this bond or this bond, any one I will take. Now what will happen? This bond is going to get cleaved and there will be cleavage of this bond. In your exam, don't show all these arrows and all. So now H plus will be released. So it will be taken care by O minus, and C plus, whatever is formed, it will be taken care by O minus, right? So that's where we have the molecule COOH, O, CO, CH3. That's where we have the molecule acetyl salicylic acid. This is nothing but acetyl salicylic acid, which will be called as aspirin, right? Which we used to take tablets now, headache, or it will be used as a blood thinner, right? Aspirin, acetyl salicylic acid. What should be another product? O minus, because of OH bond cleavage, O minus will be taking the CH3CO, whatever plus is there, right? And whatever H plus is there, it will be taken by this oxygen, CH3COOH. That is nothing but acetic acid. CH3COOH. That is nothing but acetic acid. Any doubt? This is important. Any doubt? That's where we have the preparation of aspirin. That means esters can be formed when alcohol is treated with carboxylic acid or when alcohol is treated with acetic anhydride. Basic requirement for esterification is R CO positive. That's what. Any of these two methods can be used for esterification. But normally for aspirin, they will be using acetic anhydride. Fine? Any doubts? This is important, aspirin. They have asked this reaction, which is an example for esterification reaction. Preparation of aspirin is an example for esterification reaction, because esterification is a process where esters will be formed. Anyway, I will stop here. Tomorrow we are going to continue the reaction. Any doubts? Any doubts? No doubts? Fine. In that case, I will stop. Take care. Take care. Thank you. Thank you very much. Bye.